Welcome. Today we're going to be talking about reactance of inductors and capacitors. So, what is reactance? Reactance, simply put, is just a form of opposition generated by different elements in a circuit when alternating current flows through the circuit that will try and pretty much resist the current, almost like a resistor. And it's very similar to resistance. So, the more reactance there is in a circuit, the less the current will be because there will be more opposing force that's stopping the current from flowing. It's denoted by the symbol X and is measured in ohms. Again, very similar to resistance. Now, there are two types of reactance, inductive reactance and capacitor reactance, and they come from the inductor and the capacitor, respectively. Inductive reactance is denoted by the symbol XL and can be calculated using the formula 2 pi times FL, where F represents frequency and L represents the inductance. And similarly, capacitive reactance is denoted by the symbol Xc, can be calculated using a very similar formula. Just note the only two changes are the half value and the change from L to C, which in this case represents the capacitance. Now, is there any difference between these two types of reactance? Well, yes, there is. If we look at this equation here, we can see that this is the equation for current in a capacitor with a inductor. So we can see that the omega represents our frequency. And if we know that, we can see that the frequency will, as the frequency increases, our reactance, our inductor reactance value will also increase. Practically, this means that the voltage in the circuit will be changing quicker and quicker, which means the charges have less time to accelerate, which means the current would therefore decrease. And if we look at the capacitive resistance, we can see the inverse relationship applies. So as our frequency increases, the capacitive reactance will actually decrease because as the voltage changes quicker and quicker in the circuit, the capacitor needs to charge and discharge faster, which means more current is required. So therefore, as this increases, as this frequency increases, the reactance will then decrease. Now, the same rules apply for inductance and capacitance, respectively. We can see here, as the inductance increases, the overall reactance, the inductive reactance will also increase, and the same applies respectively here. As the capacity increases, this overall capacitive reactance will decrease. Thank you.